Enterprise content management is a formalized means of organizing and storing an organization's documents, and other content, that relate to the organization's processes. The term encompasses strategies, methods, and tools used throughout the life cycle of the content. Definition: The Association for Information and Image Management International, the Worldwide Association for Enterprise Content Management, defined the term in 2000. AIIM has refined the abbreviation ECM several times to reflect the expanding scope and importance of information management. Late 2005, enterprise content management is the technology used to capture, manage, store, preserve, and deliver content and documents related to organizational processes. Early 2006, enterprise content management is the technology used to capture, manage, store, preserve, and deliver content and documents related to organizational processes. ECM tools and strategies allow the management of an organization's unstructured information, wherever that information exists. Early 2008, enterprise content management is the strategies, methods and tools used to capture, manage, store, preserve, and deliver content and documents related to organizational processes. ECM tools and strategies allow the management of an organization's unstructured information, wherever that information exists. Early 2010, enterprise content management is the strategies, methods and tools used to capture, manage, store, preserve, and deliver content and documents related to organizational processes. ECM covers the management of information within the entire scope of an enterprise, whether that information is in the form of a paper document, an electronic file, a database print stream, or even an email. The latest definition encompasses areas that have traditionally been addressed by records management and document management systems. It also includes the conversion of data between various digital and traditional forms, including paper and microfilm. ECM is an umbrella term covering document management, web content management, search, collaboration, records management, digital asset management, workflow management, capture and scanning. ECM is primarily aimed at managing the life cycle of information from initial publication or creation all the way through archival and eventually disposal. ECM applications are delivered in three ways: on-premise software, software as a service, or a hybrid solution composed of both on-premise and SaaS components. ECM aims to make the management of corporate information easier through simplifying storage, security, version control, process routing, and retention. The benefits to an organization include improved efficiency, better control, and reduced costs. For example, many banks have converted to storing copies of old checks within ECM systems as opposed to the older method of keeping physical checks in massive paper warehouses. Under the old system, a customer request for a copy of a check might take weeks, as the bank employees had to contact the warehouse where the right box, file, and check would need to be located. The check would then need to be pulled, a copy made and mailed to the bank where it would finally be mailed to the customer. With an ECM system in place, the bank employee simply queries the system for the customary unregistered trademark S account number and the number of the requested check. When the image of the check appears on screen, the bank is able to mail it immediately to the customer, usually while the customer is still on the phone. History: Enterprise content management, as a form of content management, combines the capture, search and networking of documents with digital archiving, document management and workflow. It specifically includes the special challenges involved in using and preserving a company's internal, often unstructured information, in all of its forms. Therefore, most ECM solutions focus on business-to-employee systems. As ECM solutions have evolved, new components have emerged. For example, as content is checked in and out, each use generates new metadata about the content, to some extent automatically. Information about how and when the content was used can allow the system to gradually acquire new filtering, routing and search pathways, corporate taxonomies and semantic networks, and retention rule decisions. Email and instant messaging are increasingly employed in decision-making processes. ECM can provide access to data about these communications, which can be used in business decisions. Solutions can provide intranet services to employees, and can also include enterprise portals for business to government, government to business, or other business relationships. This category includes most former document management groupware and workflow solutions that have not yet fully converted their architecture to ECM, but provide a web interface. Digital asset management is a form of ECM concerned with content stored using digital technology. The technologies that comprise ECM today are the descendants of late 1980s and early 1990s electronic document management systems. The original EDMS products were standalone products, providing functionality in one of four areas: imaging, workflow, document management, or ERM. The typical early EDMS adopter deployed a small-scale imaging and workflow system, possibly to just a single department, in order to improve a paper-intensive process and migrate towards the mythical paperless office. The first standalone EDMS technologies were designed to save time or improve information access by reducing paper handling and paper storage, thereby reducing document loss and providing faster access to information. EDMS could provide online access to information formerly available only on paper, microfilm, or microfiche. By improving control over documents and document-oriented processes, EDMS streamlined time-consuming business practices. The audit trail generated by EDMS enhanced document security, and provided metrics to help measure productivity and identify efficiency. Through the late 1990s, the EDMS industry continued to grow steadily. The technologies appealed to organizations that needed targeted, tactical solutions to address clearly defined problems. As time passed, and more organizations achieved pockets of productivity with these technologies, it became clear that the various EDMS product categories were complementary. Organizations increasingly want to leverage multiple EDMS products. Consider, for example, a customer service department where imaging, document management, and workflow could be combined to allow agents to better resolve customer inquiries. Likewise, an accounting department might access supplier invoices from an ERM system, purchase orders from an imaging system, and contracts from a document management system as part of an approval workflow. As organizations established an internet presence, they want to present information via the web, which required managing web content. Organizations that had automated individual departments now began to envision wider benefits from broader deployment. Many documents cross multiple departments and affect multiple processes. The movement toward integrated EDMS solutions merely reflected a common trend in the software industry, the ongoing integration of point solutions into more comprehensive solutions. For example, until the early 1990s, word processing, spreadsheet, and presentation software products were standalone products. Thereafter, the market shifted toward integration. Early leaders already offered multiple standalone EDMS technologies. The first phase was to offer multiple systems as a single, packaged suite, with little or no functional integration. Throughout the 1990s, integration increased. Beginning in approximately 2001, the industry began to use the term enterprise content management to refer to these integrated solutions. In 2006, Microsoft and Oracle Corporation joined established leaders such as Inc. Documentum, Laserfic and OpenText and entered the entry-level value market segment of ECM. Open-source ECM products are also available, including Alfresco, ExoPlatform, LogicalDoc, SenseNet, EZPublish, Knowledge Tree, Jumper 2.0, Nuxio, and Plone. Government standards, including HIPAA, SAS 70, BS 7799 and ISO IEC 27001, are factors in developing and deploying ECM. Standards compliance may make outsourcing to certified service providers a viable alternative to an internal ECM deployment. Today, organizations can deploy a single, flexible ECM system to manage information in all functional departments, including customer service, accounting, human resources, etc. Adoption drivers, There are numerous factors driving businesses to adopt an ECM solution, such as the need to increase efficiency, improve control of information, and reduce the overall cost of information management for the enterprise. ECM applications streamline access to records through keyword and full-text search, allowing employees to get to the information they need directly from their desktops in seconds rather than searching multiple applications or digging through paper records. These management systems can enhance record control to help businesses to comply with government and industry regulations such as HIPAA, Sarbanes-Oxley, PCI-DSS, and the Federal Rules of Civil Procedure. Security functions including user-level, function-level and even record-specific security options protect your most sensitive data. In fact, even information contained on a specific document can be masked using redaction features, so the rest of the document can be shared without compromising individual identity or key data. Every action taken within the system is tracked and reportable for auditing purposes for a wide variety of regulations. ECM systems can reduce storage, paper and mailing needs, make employees more efficient, and result in better, more informed decisions across the enterprise, all of which reduce the overhead costs of managing information. SaaS ECM services can convert expensive capital outlay for servers and network equipment into a monthly operating expense, while also reducing the IT resources required to manage enterprise records. Characteristics: Content management includes ECM, web content management, content syndication, and media asset management. Enterprise content management is not a closed system solution or a distinct product category. Therefore, along with document-related technologies or document lifecycle management, ECM is just one possible catch-all term for a wide range of technologies and vendors. The content and structure of today's outward-directed web portal will be the platform for tomorrow's internal information system. In his article in Computer Wash, Ulrich Kampmeier distilled ECM to 3 key ideas that distinguish such solutions from web content management. Enterprise content management is integrative middleware. ECM is used to overcome the restrictions of former vertical applications and island architectures. The user is basically unaware of using an ECM solution. ECM offers the requisite infrastructure for the new world of web-based IT, which is establishing itself as a kind of third platform alongside conventional host and client-server systems. Therefore, EAI and SOA will play an important role in the implementation and use of ECM. Enterprise content management components as independent services. ECM is used to manage information without regard to the source or the required use. The functionality is provided as a service that can be used from all kinds of applications. The advantage of a service concept is that for any given functionality only one general service is available, thus avoiding redundant, expensive and difficult to maintain parallel functions. Therefore, standards for interfaces connecting different services will play an important role in the implementation of ECM. Enterprise content management as a uniform repository for all types of information. ECM is used as a content warehouse that combines company information in a repository with a uniform structure. Expensive redundancies and associated problems with information consistency are eliminated. All applications deliver their content to a single repository, which in turn provides needed information to all applications. Therefore, content integration and ILM will play an important role in the implementation and use of ECM. Enterprise content management is working properly when it is effectively invisible to users. ECM technologies are infrastructures that support specialized applications as subordinate services. ECM thus is a collection of infrastructure components that fit into a multi-layer model and include all document-related technologies for handling, delivering, and managing structured data and unstructured information jointly. As such, enterprise content management is one of the necessary basic components of the overarching e-business application area. ECM also sets out to manage all the information of a WCM and covers archiving needs as a universal repository. Components. ECM combines components that can also be used as standalone systems without being incorporated into an enterprise-wide system. The 5 ECM components and technologies were first defined by AIIM as capture, manage, store, preserve, and deliver. Capture. Capture involves converting information from paper documents into an electronic format through scanning. Capture is also used to collect electronic files and information into a consistent structure for management. Capture technologies also encompass the creation of metadata that describe characteristics of a document for easy location through search technology. For example, a medical chart might include the patient ID, patient name, date of visit, and procedure as index values to make it easy for medical personnel to locate the chart. Earlier document automation systems photographed documents for storage on microfilm or microfiche. Optical scanners now make digital copies of paper documents. Documents already in digital form can be copied or linked to, if they are already available online. Automatic or semi-automatic capture can use EDI or XML documents, business and ERP applications, or existing specialist application systems as sources. Recognition technologies. Various recognition technologies can be used to extract information from scanned documents and digital faxes, including optical character recognition, converts images of typeset text into alphanumeric characters, handprint character recognition, converts images of handwritten text into alphanumerics. Gives better results for short text in fixed locations than for free-form text. Intelligent character recognition extends OCR and HCR to use comparison, logical connections, and checks against reference lists and existing master data to improve recognition. For example, on a form where a column of numbers is added up, the accuracy of the recognition can be checked by adding the recognized numbers and comparing them to the sum written on the original form. Optical mark recognition reads special markings, such as check marks or dots, in predefined fields. Barcode recognition decodes industry-standard encodings of product and other commercial data. Image cleanup features include rotation, straightening, color adjustment, transposition, zoom, aligning, page separation, annotations and despeckling. Forms processing. In forms capture, there are two groups of technologies, although the information content and character of the documents may be identical. Forms processing is the capture of printed forms via scanning. Recognition technologies are often used here, since well-designed forms enable largely automatic processing. Automatic processing can be used to capture electronic forms, such as those submitted via web pages, as long as the layout, structure, logic, and contents are known to the capture system. Cold, computer output to Laserdisc records reports and other documents on optical discs, or any form of digital storage for ongoing management by ECM systems. Another term for this is enterprise report management. Originally, the technology only worked with Laserdiscs. The name was not changed after other technologies supplanted the Laserdisc. Aggregation combines documents from different applications. The goal is to unify data from different sources, forwarding them to storage and processing systems in a uniform structure and format. Indexing components. Indexing improves searches, and provides alternative ways to organize the information. Manual indexing assigns index database attributes to content by hand, typically used by the database of a managed component for administration and access. Manual indexing may make use of input designs to limit the information that can be entered. For example, entry masks may use programmed logic to restrict inputs based on other information known about the document. Both automatic and manual attribute indexing can be made easier and better with preset input design profiles. These can describe document classes that limit the number of possible index values, or automatically assign certain criteria. Automatic classification programs can extract index, category, and transfer data autonomously. Automatic classification or categorizing, based on the information contained in electronic information objects, can evaluate information based on predefined criteria or in a self-learning process. This technique can be used with OCR-converted faxes, Office files, or output files. Manage. The manage category includes 5 traditional application areas: document management, collaboration, web content management, records management, workflow and business process management. The manage category connects the other components, which can be used in combination or separately. Document management, web content management, collaboration, workflow and business process management address the dynamic part of the information's lifecycle. Records management focuses on managing finalized documents in accordance with the organization's document retention policy, which in turn must comply with government mandates and industry practices. All managed components incorporate databases and access authorization systems. Managed components are offered individually or integrated as suites. In many cases they already include the store components. Document management. Document management, in this context, refers to document management systems in the narrow sense of controlling documents from creation to archiving. Document management includes functions like check-in, check-out, for checking stored information for consistency. Version management, to keep track of different versions of the same information with revisions and renditions. Search and navigation, for finding information and its associated contexts. Organizing documents, in structures like files, folders, and overviews. However, document management increasingly overlaps with other managed components, Office applications like Microsoft Outlook and Exchange, or Lotus Notes and Domino, as well as library services for administering information storage. Collaboration components in an ECM system help users work with each other to develop and process content. Many of these components were developed from collaborative software, or Drupal, packages. ECM collaborative systems go much further, and include elements of knowledge management. ECM systems facilitate collaboration by using information databases and processing methods that are designed to be used simultaneously by multiple users, even when those users are working on the same content item. They make use of knowledge based on skills, resources and background data for joint information processing. Administration components, such as virtual whiteboards for brainstorming, appointment scheduling and project management systems, communications applications such as video conferencing, etc., may be included. Collaborative ECM may also integrate information from other applications, permitting joint information processing. Web content management, the scope of enterprise content management integrates web content management systems. WCM as ECM component is used to present information already existing and managed in the ECM repository. However, information presented via web technologies on the Internet, an extranet, or on a portal uses the workflow, access control, versioning, delivery and authorization modules of the WCM instead of integrated ECM functionality. There are only few examples of successful implementations whereby a shared repository for documents and web content are managed together. Records management, unlike traditional electronic archival systems, records management refers to the pure administration of records, important information, and data that companies are required to archive. Records management is independent of storage media. Managed information does not necessarily need to be stored electronically, but can be on traditional physical media as well. Some of the functions of records management are visualization of file plans and other structured indexes for the orderly storage of information, unambiguous indexing of information, supported by thesaurial-controlled word lists, management of record retention schedules and deletion schedules, protection of information in accordance with its characteristics, sometimes down to individual content components in documents, use of international, industry-specific or company-wide standardized metadata for the unambiguous identification and description of stored information. Workflow business process management. Workflow and business process management differ substantially. Workflow. There are different types of workflow. Production workflow uses predefined sequences to guide and control processes, whereas in an ad hoc workflow, the user determines the process sequence on the fly. Workflow can be implemented as workflow solutions with which users interact, or as workflow engines, which act as a background service controlling the information and data flow. Workflow management includes the following functions: visualization of process and organization structures, capture, administration, visualization, and delivery of grouped information with its associated documents or data, incorporation of data processing tools and documents, parallel and sequential processing of procedures including simultaneous saving, reminders, deadlines, delegation and other administration functionalities, monitoring and documentation of process status, routing, and outcomes, tools for designing and displaying process. The objective is to automate processes as much as possible by incorporating all necessary resources. Business process management, definitions cited from AIIM, BPM is a way of looking at and then controlling the processes that are present in an organization. It is an effective methodology to use in times of crisis to make certain that the processes are efficient and effective, as this will result in a better and more cost-efficient organization. Business process management goes a step further than workflow. Although the words are often used interchangeably, BPM aims to completely integrate all of the affected applications within an enterprise, monitoring processes and assembling all required information. Among BPM's functions are: BPM offers complete workflow functionality, providing process and data monitoring at the server level. Enterprise application integration is used to link different applications. Business intelligence, with rule structures, integrates information warehouses and provides utilities that assist users in their work. Store components temporarily store information that isn't required, desired, or ready for long-term storage or preservation. Even if the store component uses media that are suitable for long-term archiving, store is still separate from preserve. The store components can be divided into three categories: repositories as storage locations, library services as administration components for repositories, and storage technologies. These infrastructure components are sometimes held at the operating system level, and also include security technologies that work in tandem with the deliver components. However, security technologies, including access control, are superordinated components of an ECM solution. Repositories. Different kinds of ECM repositories can be used in combination. Among the possible kinds are file systems. File systems are used primarily for temporary storage, as input and output caches. ECM's goal is to reduce the data burden on the file system, and make the information generally available through manage, store, and preserve technologies. Content management systems. This is the actual storage and repository system for content, which can be a database or a specialized storage system. Databases administer access information, but can also be used for the direct storage of documents, content, or media assets. Data warehouses. These are complex storage systems based on databases, which reference or provide information from all kinds of sources. They can also be designed with global functions, such as document or information warehouses. Library services. Library services are the administrative components of the ECM system that handle access to information. The library service is responsible for taking in and storing information from the capture and manage components. It also manages the storage locations in dynamic storage, the actual store, and in the long-term preserve archive. The storage location is determined only by the characteristics and classification of the information. The library service works in concert with a managed components database to provide the necessary functions of search and retrieval. While the database does not know the physical location of a stored object, the library service manages online storage, nearline storage, and offline storage. If the document management system does not provide the functionality, the library service must have version management to control the status of information, and check-in check-out, for controlled information provision. The library service generates logs of information usage and editing, called an audit trail. Storage technologies. A wide variety of technologies can be used to store information, depending on the application and system environment. Magnetic online media, hard drives, typically configured as RAID systems, may be locally attached, part of a storage area network, or mounted from another server. Magnetic tape. Magnetic tape data storage, in the form of automated storage units called tape libraries, use robotics to provide nearline storage. Standalone tape drives may be used for backup, but not online access. Digital optical media, besides the common compact disc and DVD optical media in write-once or rewritable forms, storage systems may use other specialized optical formats like magneto-optical drives for storage and distribution of data. Optical jukeboxes can be used for nearline storage. Optical media in jukeboxes can be removed, transitioning it from nearline to offline storage. Cloud computing, data can be stored on off-site cloud computing servers, accessed via the Internet. Preserve involves the long-term, safe storage and backup of static, unchanging information. Preservation is typically accomplished by the records management features of an ECM system, and many are designed to help companies comply with government and industry regulations. Eventually, content ceases to change and becomes static. The preserve components of ECM handle the long-term, safe storage and backup of static information, as well as the temporary storage of information that does not need to be archived. Electronic archiving, a related concept, has substantially broader functionality than ECM preserve components. Electronic archiving systems generally consist of a combination of administration software like records management, imaging or document management, library services or information retrieval systems, and storage subsystems. Other forms of media are also suitable for long-term archiving. If the desire is merely to ensure information is available in the future, microfilm is still viable. Unlike many digital records, microfilm is readable without access to the specialized software that created it. Hybrid systems combine microfilm with electronic media and database-supported access. Long-term storage systems require the timely planning and regular performance of data migrations, in order to keep information available in the changing technical landscape. As storage technologies fall into disuse, information must be moved to newer forms of storage, so that the stored information remains accessible using contemporary systems. For example, data stored on floppy disks becomes essentially unusable, if floppy disk drives are no longer readily available. Migrating the data stored on floppy disks to compact disks preserves not only the data, but the ability to access it. This ongoing process is called continuous migration. The preserve components contain special viewers, conversion and migration tools, and long-term storage media. Long-term storage media, worm optical disk, write-once read many rotating digital optical storage media, including the 5.25 inches or 3.5 inches worm disk in a protective sleeve, as well as CD and DVD-R. Recording methods vary for these media, which are held in jukeboxes for online and automated nearline access. Worm tape, magnetic tapes used in special drives, that can be as secure as optical write-once, read many media if used properly with specially secured tapes. Worm hard disk drive, magnetic disk storage with special software protection against overwriting, erasure, and editing. Delivers security similar to optical write-once, read many media. This category includes content-addressable storage. Storage networks, such as network-attached storage and storage area networks, can be used if they meet the requirements of edit-proof auditing with unchangeable storage and protection against manipulation and erasure. Microforms like microfilm, microfiche, and aperture cards can be used to back up information that is no longer in use and does not require machine processing. It is typically used only to double secure originally electronic information. Paper still has use as a long-term storage medium, since it does not require migration, and can be read without any technical aids. In ECM systems, however, it is used only to double secure originally electronic information. Long-term preservation strategies, to secure the long-term availability of information. Different strategies are used for electronic archives. The continuous migration of applications, index data, metadata and objects from older systems to new ones generates a lot of work, but secures the accessibility and usability of information. During this process, Information that is no longer relevant can be deleted. Conversion technologies are used to update the format of the stored information, where needed. Emulation of older software allows users to run and access the original data and objects. Special Viewer software can identify the format of the preserved objects and can display the objects in the new software environment. Standards for interfaces, metadata, data structures and object formats are important to secure the availability of information. Deliver. The deliver components of ECM present information from the manage, store, and preserve components. The AIIM component model for ECM is function-based, and doesn't impose a strict hierarchy. The deliver components may contain functions used to enter information into other systems, or for readying information, such as by converting its format or compressing it, for the store and preserve components. The deliver category's functionality is also known as output. Technologies in this category are often termed output management. The deliver components break down into three groups: transformation technologies, security technologies, and distribution. Transformation and security, as services, are middleware and should be equally available to all ECM components. For output, two functions are of primary importance: layout and design, with tools for laying out and formatting output, and publishing, with applications for presenting information for distribution and publication. In short, ECM delivery provides information to users. Secure distribution, collaboration, and version control take the forefront. In some cases, these components are still deployed as standalone systems without being incorporated into an enterprise-wide ECM system. Transformation technologies. Transformations should always be controlled and trackable. This is done by background services that the end user generally does not see. Among the transformation technologies are computer output to Laserdisc, unlike its use in the capture stage, when used for delivery called prepares output data for distribution and transfer to the archive. Typical applications are lists and formatted output. These technologies also include journals and logs generated by the ECM components. Unlike most imaging media, cold records are indexed not in a database table, but by absolute positions within the document itself. As a result, cold index fields are not available for editing after submission unless they are converted into a standard database. Personalization, functions and output can be customized to a particular user's needs. XML, a computer language that allows the description of interfaces, structures, metadata, and documents in a standardized, cross-platform manner. PDF, a cross-platform print and distribution format. Unlike image formats such as TIFF, PDFs permit content searches, the addition of metadata, and the embedding of electronic signatures. When generated from electronic data, PDFs are resolution independent, allowing crisp reproduction at any scale. XPS, an XML specification developed by Microsoft, describing the formats and rules for distributing, archiving, rendering, and processing XPS documents. Converters and viewers serve to reformat information to generate uniform formats, and also to display and output information from different formats. Compression, used to reduce the storage space needed for pictorial information. Syndication, used for presenting content in different formats, selections, and forms in the context of content management. Syndication allows the same content to be used multiple times in different forms for different purposes. Security technologies are available to all ECM components. For example, electronic signatures are used not only when documents are sent, but also in data capture via scanning, in order to document the completeness of the capture. Public key infrastructure is a basic technology for electronic signatures. It manages keys and certificates, and checks the authenticity of signatures. Other electronic signatures confirm the identity of the sender and the integrity of the sent data, that is, that it is complete and unchanged. In Europe, there are three forms of electronic signatures, of different quality and security: simple, advanced, and qualified. In most European states, the qualified electronic signature is legally admissible in legal documents and contracts. Digital rights management and watermarking are used in content syndication and media asset management, to manage and secure intellectual property rights and copyrights. Digital rights management works with techniques like electronic watermarks that are integrated directly into the file, and seeks to protect usage rights and protect content that is published on the Internet. Distribution: all of the above technologies serve to provide an ECM's contents to users by various routes, in a controlled and user-oriented manner. These can be active components such as email, data media, memos, and passive publication on websites and portals where users can get the information themselves. Possible output and distribution media include: the various deliver components provide information to users in the best way for the given application, while controlling its use as far as possible. Methods: on-premise ECM was developed as a traditional software application that companies implemented on their own corporate networks. In this scenario, each individual company manages and maintains both the ECM application, and the network storage devices that store the data. Many on-premise ECM systems are highly customized for individual organizational needs. A note about capture: since paper document capture requires the use of physical scanning devices, like scanners or multifunction devices, it is typically performed on-premise. However, it can be outsourced to businesses that provide scanning services. Known as service bureaus, these companies complete high-volume scanning and indexing and return the electronic files to organizations via web transfer or on CDs, DVDs, or other external storage devices. Software as a Service SaaS ECM means that rather than deploying software on an in-house network, users access the application and their data online. It is also known as cloud computing, hosted, and on-demand. As SaaS distribution technologies mature, businesses can count on receiving the same features and customization capabilities they have come to expect from on-premise ECM applications. SaaS delivery allows companies to more quickly begin using ECM, since they do not have to purchase hardware or configure the applications, databases, or servers. In addition, organizations trade the capital costs associated with the hardware and software purchase for a monthly operating expense and storage capabilities that grow automatically to accommodate company growth. Hybrid: in some scenarios, companies find a hybrid composed of both SaaS and on-premise software work best for their situation. For example, hybrid ECM systems are being used to bridge the gap during company moves or to simplify information exchange following an acquisition. Hybrid is also being used when companies want to manage their own ECM on-premise, but also provide easy web access to certain information for business partners or customers using a SaaS model. Hybrid makes the most sense when the two technologies are provided by the same manufacturer, so that features and interfaces are an exact match. ECM market development: prior to 2003, the ECM market was dominated by a number of medium-sized independent vendors that fell into two categories: those who had originated as document management companies and had begun adding on management of other enterprise content, and those who had started as web content management providers and had begun trying to branch out into managing other types of content such as business documents and rich media. Larger vendors, such as IBM and Oracle, also had offerings in this space, and the market share remained largely fragmented. In 2002, Documentum had added collaboration capabilities with its acquisition of eRoom, Interwoven and Vignette countered with their respective acquisitions of iManage and Introspect. Similarly, Documentum purchased Bulldog for its digital asset management capabilities, while Interwoven and OpenText countered with acquisitions of MediaBin and Artesia. OpenText also acquired European companies IXOS and Red Dot to shore up its software portfolio. In October 2003, Inc. Corporation acquired Documentum. Soon Inc.'s primary competitors in the database space responded as IBM purchased FileNet and Oracle purchased Stellent in 2006. OpenText also purchased Hummingbird in 2006. Hewlett-Packard entered the ECM space with its acquisition of Australian company Tower Software in 2008. In March 2009, Autonomy purchased Interwoven, in July 2009 OpenText acquired Vignette, and in February 2011 OpenText acquired MetaStorm. Most recently, OpenText acquired Global 360 in July 2011, and HP made an agreement to purchase Autonomy in August 2011. In April 2007, independent analyst firm CMS Watch noted that some of the biggest names in this business are undergoing substantial transformation that will lead to shifting roadmaps and product sets over the next few years. In addition, 2007 saw the emergence of open-source options for ECM supplied by Nuxeo and Alfresco, along with a software-as-a-service offering from SpringCM. In 2008, SenseNet released SenseNet 6.0, an open-source ECM and EPS solution. There are a number of software companies that have sprung up to develop applications to complement ECM with specific functions and features. There are companies that provide third-party document and image viewers such as LED Technologies, Microsoft, and Equalsoft. There are companies that provide workflows such as Office Gemini, SpringCM, and DocAssist. There are also several companies that provide plugins for ECMs. The Web 2.0 wave brought new players to the market with strength in web-based delivery. Coral, Box.net, and EchoSign, all available on the Salesforce.com App Exchange platform, are representative of this trend. Gartner estimated that the ECM market was worth approximately $3.3 billion in 2008. This was expected to grow at a compound annual growth rate of 9.5% through 2013. After a plethora of industry consolidation, only 3 or 4 major companies are left in this space, and the industry as a whole is undergoing a significant transformation as Microsoft commoditizes content management components. According to Gartner's 2010 report, 75% of Global 2000 companies were highly likely to have a desktop-focused, process-focused content management implementation by 2008, and ECM would continue to absorb other technologies, such as digital asset management and email management. Gartner also predicted that there will be further market consolidation, acquisition, and separation of vendors into platform and solution providers. The same Gartner report classifies enterprise content management systems into 4 main categories. First, transactional content management solutions. These systems focus on imaging, capture, business process management and workflow, records management and compliance, search and e-forms. Examples: Hilans on Base, Lexmark's Perceptive Software, Weritis Technologies Records Studio. Another category is social content management. As its name suggests, these systems focus on social web content like wikis, blogs, videos, browser or portal viewing, etc. Example: Alfresco. The online channel optimization systems are mainly web content management and digital asset management systems. Examples: Autonomy, WordPress. The fourth category is content management as infrastructure. These are vendor solutions that are used as enterprise content management platforms with all the core functionalities of the other types of content management systems, but the focus is on building solutions on top of the platform. Examples: IBM FileNet, Microsoft SharePoint, Alfresco, Weritis Technologies Records Studio. In a nod to the growing importance of simpler, cloud-based file sharing systems among enterprise customers, analyst firm Real Story Group began to include such players as Box.net and Workshare in its 2014 evaluations of major ECM vendors. References. See also: Content Management Interoperability Services, Enterprise Content Integration, Enterprise Output Management, Information Governance, Information Science, List of Content Management Systems, Repository Open Service Interface Definition, Footnotes. Bibliography.